Okay, hi everyone who's joining us. This is the Chameleon webinar for Chia Edge with Mike Sherman. We're just going to give it a little bit of time, let people get settled into the Zoom room. But thank you all for joining us. We're excited you're here. And Mike has a great presentation, great webinar for us today.
Oh, I hope
Uh,
I do. I saw a lot of friendly faces in the signups.
Yeah, and we'll have plenty of time at the end for questions, for uh, comments. Feel free to either use the raise hand function at the bottom of the Zoom window. You can also if you raise your hand at any point, I'll go ahead and unmute you so that you can ask your question. You can also use the Q&A feature at the bottom as well to ask questions in the chat. We'll try to answer questions as much as we can throughout the presentation if you have questions. However, probably wait for breaks and stuff so that I'm not cutting Mike off or anything. Otherwise, we'll just address questions at the end, and I'll make sure that I repeat the instructions there for how to ask questions. We are recording today's webinar, so we will release this recording on our YouTube channel, and we'll probably post the slides as well. So you can always come back and rewatch any parts of this that you want to. As well as share with some of your colleagues if you find what we have to present today to be interesting. The last thing I'll mention is we're going to be stopping the recording during the question Q&A. So we'll have a little bit more freedom for people to participate. You don't need to worry about being recorded. And then last thing before I hand it over to Mike, we'll have we'll have another webinar for next month. This is going to be with a group of Chameleon users who are working on a project called Mincer. This is called MINCER. It's a performance measurement and reproducibility appliance that they've developed specifically for Chameleon Cloud. So if you ever tried to reproduce HPC experiments across different hardware configurations, or you've struggled with getting consistent performance measurements, this webinar may be a good thing to check out. They're going to be presenting their standardized framework to help exactly with those kinds of problems. So they'll be talking through how you can use this tool on Chameleon, including some demonstration with real proxy applications. So anyways, with that, I'll hand it over to Mike. I've been talking long enough, and it looks like we've gotten a decent amount of people in the room now. So Mike, please take it away.
Okay. So I guess where I'll start is that I know we've probably got a wide range of sort of experience levels and backgrounds. So I'm going to be starting with some overview of what is Chameleon and why use it, and what is Chia Edge and why use it. I know some of you have used it before. So I'm going to go through this first part a little bit quickly since we do have other resources on it. But this is also where, if something doesn't make sense or if there's missing context, this would be a great place for, asking one of these questions in chat or the raised hand, so that we can cover it in the Q&A. So actually, sort of getting to it. So my name is Mike Sherman. I'm the infrastructure lead for Chameleon, and I'm also the primary developer and sort of driving force behind Chia Edge, which is our edge test bed. And so what does all this mean? So for Chameleon, because it's a test bed, our goal is to provide hardware and tools and an environment that can meet the needs of your experiments. And so this means we need interesting hardware. We need ways to configure this hardware and configure it at a low enough level that you can actually get at the interesting parts. So the rest of Chameleon, we have lots of bare metal. We have the increasingly utilized virtual machine portion, and we have containers at the edge. And these are containers not just for the sake of having containers, but because this is the way we were able to provide access to peripherals and sort of the hardware details in this context. Chameleons has been really well used over the past years. We've got our sort of headline slide that we always go through, but we've had some really great numbers lately. It's been really exciting to see people using things. Um, and this, I think, means that access to this hardware has been really useful to people. And my goal is I'd like to make sure that Chi Edge can be useful in the same ways. This is again just kind of a brief run through of where does Chi Edge fit in terms of the rest of Chameleon's hardware and sites and all the stuff, as it were. So what we see here is that at the bare metal sites, this is where we have the big nodes, things with tons of CPU cores, very fast networks, lots of storage. Cheat Edge fits into this, where you want to have something at the edge, have something in an interesting context, have experiments that actually rely on how does this work on this resource constrained device. You're not going to use Cheat Edge because you want to do general purpose computation, or if that's your goal, you might be better served with one of the other sites. But it's well placed to use it in conjunction with the other sites. Everything's connected over the public internet, and so you'll be able to put the part that actually matters, the sensor, the data aggregation, any sort of pre-computation at the edge, and then feed this data back over to one of the other sites if you need to do something heavyweight. The examples I've got coming up in a bit are going to be on a bunch of different ways to actually get this data, out of the device. I've been talking a little bit about experiments. When I say experiment workflow, there is actually a sort of standard pattern that we refer to. And by this, we tend to mean the steps of you first need to discover what resources even exist. What kind of hardware, what kind of devices, what peripherals, where is it? What is even there that you want to use? You then want to make sure that it's actually allocated for your experiment and you have this exclusive use so that you can get reliable results out. And then you need to configure it so that it can actually serve your experiment. For bare metal, this is where it gets rebooted, where we put disk images on it. For Edge, this is where we push a container onto it, set environment variables, and do the things to actually let you access the hardware. And then finally, you've got some code, something that actually needs to run and perform the experiment. And finally, you need to get the results out and do something with it. So, why are we doing this? Well, there's more and more use cases where people really, really need things at the edge, not just in the cloud. Either it's inherent to the problem with federated learning, although you could do this in sort of a multi-cloud case, or if you have sensors, it sort of matters that the sensor is looking at something real. And you can't do that without having at least something there at the edge. Our goal with all of this is to try to see, can we not just make this available, but can we make this nice to use? Can we make can we make it so that it feels natural to run these experiments and access things? And for places where there's still friction, what can we do to incrementally improve this? So Again, this is sort of restating things a few times, but we've got a whole bunch of different types of peripherals. When I say peripherals, I mean more or less anything that would work if you plugged it into a Raspberry Pi and knew nothing about Chameleon. We try to be pretty agnostic, and so generally, if it can plug into one of these general purpose single board computers that people use in this context, there's a way to make it work in She Edge, although the more complicated ones, we might need to deal with some edge cases. We're also strongly focused on the bring your own device model. Again, the devices aren't super useful if they're all sitting in our data center somewhere or our IoT lab. So it's important that you're able to add and use your devices. And one of the important features I mentioned here is you're able to use peripherals with your own devices, and you're also able to share those devices, either limit it to only your project, or share it with everyone, or some subset. And so we've had some people use this, for example, to use it in a classroom context. So I want members of these two projects who are in my class to be able to use this device, but not others. I'm going to actually switch over to a different screen in a second. So this is a quick overview of what are the sort of normal devices that are fully supported in Shield Edge. It's right now this is a short list because these are the ones that sort of we own and we have examples for. And they're mostly here as examples of what is the usage style and the interfaces. And now, because this is just a slide, in a second, I'm going to switch over to our documentation page that actually lists all of this with a lot more details. The main takeaway here is, most things that are a Pi hat work, all the Pi cameras work, the current generations of Raspberry Pi and Jetson Nano and Jetson Xavier. Um, and in the pipeline in the next couple months, we've got the sort of newer, beefier Jetson Nanos coming. This page here is just for reference because we'll share the slides. We've got a updated documentation page, and let me switch my screen share over to that. So this is linked to from the Chameleon page as well. This is our sort of landing page for the documentation now. So this is lists the recent papers. This will bring you to the graphical user interface. It lists to the upcoming examples. Uh, but importantly, this also lists, what are the devices we have? What are they named when you want to use them? How do you find out more information? Where's the specifications? And then similarly for all of the peripherals coming up, you can look at this page, and this is a currently not exhaustive but growing list of what are devices that have peripherals and how do you access that peripheral and where do you go for more details. Especially many of these peripherals have many, many features. And so it's more than we can cover in a single documentation page or examples, but you'll be able to use things at a low level if that's what you need to do. And finally, we also have a live hardware table. Again, this is currently not including all of the information that we had in the docs there, but eventually it's all going to live here and you'll be able to come here for a up-to-date list of everything that we've got and what it has and how to use it. Let's see. Sorry, just hunting around for the share screen button here. So after this, we So after this, I'm just hopping into a few of our examples here. So the first thing is I was mentioning this discover aspect. So we've got that documentation page with what devices we have, what peripherals they have, and you know where to find them. And then these examples are about how to use them. The one I'm going to start with here is for using the Pi camera peripherals. And in the vein of cooking shows, I've got a tab here of I've prepared this in advance, um, and then we've got this tab over here that we have cleaned up so we can follow along. So let's just clear all the outputs. So what we're doing here first is authenticating to Edge and picking what project to use. I happen to be on a whole pile of them, so I have to pick the one I want to use here. Then the first thing we're going to do is find out what hardware we want. This also, if anything is too small, I should say, please make a comment and I can update the font size. So the first part here is just finding out what hardware is available. Our Python library provides this hardware module and this get devices. And so what this is saying is give me a list of all of the devices that are a Raspberry Pi 4 and aren't currently reserved. And then because I know from that documentation page that all of the ones with cameras happen to start with this string, let's print out a list of just all of those. And we see that this one is currently available for reservation. If we set this to false, this will show us a bunch of other ones that are currently in a reservation. And then this is one of the things where once we get more peripheral information into that database, this interface will get richer, and you'll be able to say, give me only things with a Pi camera 3, for example. So over here, I see if the one that's available is the IoT or Pi 4 PyCam 2. We can either just pick the one off the list here or pick one by name. And I'll just go in here and wait for this list to start. This is the allocate devices step. And then I will want to actually launch a container on this. There's a bunch of arguments here, but the reason they're all here, or there's a reason they're all here. One of them is the container image here. This is a Docker image that we've provided that has all of the dependencies and libraries and other stuff to make this work well, and also to keep it in a compact image that's not too large. We're not doing anything over the network here, so we haven't exposed any ports. This is just using the lease that we made above. Because we're doing this interactively, we're telling the container to just sleep forever and not exit. This keeps it running. And then we're going to pass these device profiles when we launch it. This is what actually tells Edge to, when you launch the container, make the devices that the camera needs accessible. And the list I passed here, this is a list I took from the documentation page. I looked up this device that we reserved. That one has a Pi camera 2, and so for that one, we pass this device profile and it passes in the things we need. And so now we have a container that's running. By itself, this doesn't give us a ton of information, and there's a few different ways we can go about trying to find that information. One of them would be to go over to the graphical interface. So we'll refresh this. We know that we launched this container. We can go look at the logs, which is nothing. We can open a graphical console. We can poke around in here. We can see what's available under /dev. And here, this is actually where we see, because we passed in that device profile, all of these video devices and accelerated memory access and these media devices, all of these are provided by the libcamera driver stack if the correct things are passed in from the host device. And so this is how we make that available. We pop back over here, we can also actually ask this driver stack to sort of confirm it's working. And the way we're doing this is with Python Cheese command execute feature, where we're just telling, right now we're just telling it, hey, use bash and run this command, and then tell us, show us what standard out is. And this matches our assumptions because from the documentation, we saw that that was a PyCamera 2, and we see our IMX219 here. And this all seems to be working. If we hadn't passed in the device profile, this would have raised an error. Now we also want to actually do something with the camera, and that's going to be difficult with the sort of web terminal console there. And so instead, we can do a few different things to move files around. And so this command, we're just going to tell it, hey, take an image and save it to this path locally on the device. And then once it's done that, copy that image back into our Jupyter environment so we can look at it. And so this is using execute, and then it's using download. This is showing a white background, which may be a little bit difficult to see. This did actually work. It just happens to be pointing at the ceiling next to my desk over at UChicago. And so it's not super interesting, but with a device in a more useful place, you would see a more interesting image there. Now, this is with the commands. It's also of interest to see, well, how do you do something a little bit more programmatic? So you have software you want to push somewhere, you have scripts you want to iterate. And so for that, instead, we can write a Python script to use the same library. And so this is just a very simple kind of hello world, please capture one image example. But this is code that you could use in any Python project in Edge to access the camera. The nice part about PyCamera 2 and this libcamera library, the nice part is it works with all of the Raspberry Pi cameras. It's a sort of a single unified interface. And so what we're actually going to do is we've got this camera test. We can edit it. We can do whatever we want here. And so we're actually going to push this script over to the device and then execute it. And then we can do the same thing where this has saved an output file. We can copy it back and view it. And the good news is it's the same image. The bad news is it's still the same image, which doesn't have a lot of detail there. The same process can also be used for capturing video. Oh, whoops. My screen is a little bit cut off. Just saw that. Is this better? Zoom is showing me the screen borders, but cool. We can also do this with video. This will take a bit longer because the file is bigger. Unfortunately, I'm not going to be able to show this to you easily because the Raspberry Pi doesn't have a sort of accelerated video in encoding support that also works in the browser. And so we can totally get the video files out. It's just that it's a little bit difficult to quickly display it here. And then when we've run through all of this, you can also either just wait for the lease to expire, at which point things will get cleaned up automatically. We made a 3 hour long lease. Or if we want to do other things, we can go ahead and manually delete the container and or the lease early and just clean up after ourselves. Particularly deleting the container is something you'll want to do if you want to relaunch with other parameters, because you can accidentally leave a number of sort of containers running in the background, and sometimes those will compete to access things. One of our other devices here, just to show that things do actually sometimes have data in the image. This is pointing, or this was a few days ago. This was pointing at a nice chameleon sign. I think it has swiveled slightly, and so we'll get some nice things for cameras to point at. And after this, I have a few more examples about accessing other kinds of sensors and interactive usage, but I did want to stop for a second and ask if anyone had questions about the examples shown here. And I mentioned that just because I at least found the iterative workflow of being able to uh, modify code in a reasonable editor and push it and run it and get it back was quite helpful. And at the end of it, you end up with things in one of these notebook environments, which you can turn into a shareable artifact. And actually, this is a shareable artifact, and I've linked to this in the slide, so you'll be able to go through and try these out yourself afterwards. If there's no questions on this, what I'm going to do is I'm going to hop over to the next example, which is instead of accessing cameras, it's accessing some lower level sensors. And this is with the Sense Hats and GPIO artifact. So this is, again, very similar, where we're using Chia Edge, we're picking a project. We make a lease for the device we wanted. In this case, this device with the Pi Camera 3 happens to be the same one that has one of the Sense hats on it. And so there's a little bit of contention just because it's the same device with two kinds of things, but this will be a bit better as we add more stuff. This particular example is using the Raspberry Pi sort of official Sense hat. It has a supported official library for interacting with it. Has all sorts of details. You can buy it from anyone. And so I mentioned this because it's a nice packaging of a bunch of basic environmental sensors. And then what we do here is we launch a container in exactly the same way, except instead of the camera, we're using this Pi Sense Hat device profile. And this passes in stuff like the I2C interface. It passes in the frame buffer because the Pi Sense Hat actually has a little LED grid on it. So if you've got one locally, you can make it print out little words or display pictures and other fun little things there. But it also has a whole list of different basic sensors. So we've got pressure and temperature sensors and humidity sensors. It's got all sorts of orientation information from a combo accelerometer and gyroscope and magnetometer. And so this is a nice example of just how would you get at sensor data attached to a Chia Edge device. This is a similar pattern to what I was showing with the cameras, where we've got a minimal little Python script It's just here I'm running this as a string and just passing it in instead of copying a file over. But they're all valid ways to do this. So we run this command. It takes a second, gets the result back. This is printing out, oh, we've got pressure. We've got a couple different temperature readings because there's actually two different sensors that have temperature. And it's claiming that it's 20% relative humidity where the device is. You can also, if you're so inclined, poke around at a lower level. And this is just using that library, but we can, because we can access the I2C interface, we can see everything that's attached. We can look at the docs and say, oh, I've got something on 6A over here. That's one of the interfaces to the IMU, and so on and so forth, digging around there. This is maybe not the most interesting example because the Raspberry Pi official hat has I guess such a good library. We also have this WaveShare hat, which has almost all the same sensors, but it's from a different vendor, a little bit different packaging. We've done the same thing. We looked up what device has it. We made a lease for that device, waited for the lease to become active. Um, the reason I showed this example is this shows some of the edge cases in making things work, especially making libraries work that were written for a sort of native Raspberry Pi OS environment. And so here, what we're having to do is actually specify a number of environment variables. What this code wants to do is it wants to look up what kind of Raspberry Pi am I running on from some things that the kernel makes available under the /sys device tree information. And unfortunately, that's one of the paths that we don't currently make available inside your container in SheetEdge. It's on the host, but the sort of security settings currently prevent us from letting stuff inside your container see it. Because we would have to either, basically, right now, if we were to make that information available, it would also give your container root access to everything. And that affects our ability to keep the devices reliable and online. And so instead, for this device, we went and looked up the documentation for the WaveShare Sense Hat and what libraries it uses. And in that documentation, it says, here's what it tries to look up, but you can also override it and set it manually if for whatever reason you can't look it up. This is generally the pattern you can follow as an escape hatch, is if you happen to depend on something purely for informational reasons, it's not needed for functioning, but just for discovery, there's almost always a way to pass in this information as a workaround. So we do this. Again, we've got our documentation saying what sensors are there, what I2C addresses are they listening on, and now how do we access these? So this one, we have a bunch of example scripts included under this examples directory. And it's showing, here's how to, we're going to define each input. We're going to say what that input means and have a little bit of scripting around to read this and to pretty print it. So we've got all of these scripts here, and we can just go back and same as we did before. Here we are just executing that script file. And get our little results out. This is reading the same kind of sensors in the same kind of fashion. This is just showing different libraries in a lower level way to get at it. And so you can extend this approach to basically anything that can be attached to the device's GPIO pins, whether over SPI or I2C or an analog input. Feel free to use these as sort of reference examples. Many of the existing GPIO libraries work fine, and all they want is for you to tell it what pin to use. And these container images we provide have all of those libraries included, and so you can use those as a base. The Again, I can kind of stop here and handle any questions if there's questions or comments or anything people would like me to elaborate a little bit more on. Um, what I've got coming next is a example of more interactive use where instead of working through the notebook interface, where we're actually going to connect to a device over SSH into a container and poke around that way. The goal of that is that there's cases where the upload a file, execute it, get the results back flow can be a bit restrictive or slow. And so you can want to, poke around and explore and find things out yourself. But the trade-off is you lose the reproducibility aspect, where the advantage of having this all in the notebook is we have all of the results and all of the steps we took here. But that trade-off is something you sometimes just have to make when you're doing something exploratory versus more rigorous. Let's see. There's nothing there. I can kind of move on to the next thing. Uh, Gotcha. Yep. So yeah, I can move on to the next thing. There will also be some Q&A time at the end, especially since I'm gonna have some questions on my side about what kind of peripherals people are looking for and how we can make this work better with sort of your own devices. And so sort of keep that in mind as I'm working through this. The next example is this Chi SSH on to containers. This is the third one that was linked from the slide and is also linked from our docs and from Trovy. This one, because I didn't need anything in particular, I asked it to just give me any Raspberry Pi 4, and so I just picked one, the first one off the list, and I started it up with, again, this image we provide. And this is a very boring image. All it does is it includes the SSH daemon. And we've passed in a couple extra parameters to have it listen on port 22 and to have it run in the foreground the SSH daemon. This is actually something the container image will do by default, but I have it included here just to be explicit. And so how do you SSH to something? We don't want to use passwords here because this is going to be listening on a public IP address. And so instead, we're going to send it a public key. We just have this edge user public key here, which you can paste a public key into. I've pasted mine into this. It's public, so it's fine that you see this because it's the public key. When this isn't there, the default just looks like this, where it just says replace this with your public key. And then all we're doing is the same thing you would do on a Linux server. We copy the public key over. We are concatenating it into the authorized keys file. And then we're going to tell it, hey, for sanity, print out the authorized keys file so we can see which keys will allow us to SSH in. And then finally, we're attaching a public IP to this container and then just printing out how to connect to it. There's a little. Why is it cut off again? Is this visible again, or is this not visible? Let's figure out what Zoom is doing. Unfortunately, Zoom isn't giving me great feedback on whether it's cut off or not. Cool. Um, and so all we've done is associated this public IP to the container, and we'll be able to SSH as root to this, but only if we have the matching private key, which I won't show you. And actually, what I can do here is let's see if we can share my whole desktop instead of just the screen, since that will make switching easier. Ah, so is this more visible now, even though I'm not sure the cool. All right, and somewhere I left my terminal that had the right stuff for this. Yeah. So this is just terminal from my laptop, and all we're going to do is paste in this command. Should take a few seconds, and now we are running inside the container. There's a little bit of latency because it's going across a WireGuard tunnel and hopping a fair distance, but you should be able to connect your container with SSH. You should be able to, port forward an IDE to this and edit files. The main thing to be aware of is that these containers are ephemeral in terms of storage. And so if the container is, say, deleted and created again, or it's restarted, any changes you make to a file here will be lost. And so this is why we kind of recommend, for the most part, instead of making edits directly inside the container, it's better to edit files outside it and copy them in, or use a script to synchronize things, just to prevent that case from happening. Persistent storage for these edge containers is something that's on our roadmap, but it's a little bit inherently difficult due to the latency and the unreliable sort of connectivity from any given edge device to a central location. Um, Poking around in here, there's some commands that are not found. This is fully, editable. You can do whatever you want. We can do can run apt-get update. You can install things. You can make whatever changes you want here. It's just that moving lots of data around and doing IO intensive things like installing packages is going to be kind of slow. And again, will be lost the next time you launch this same container. And so what we recommend instead is if you know what dependencies you need, what tools you need, it's better to make your own Docker image, push that up to Docker Hub or any other public registry, and then use that so you don't have to spend the time installing stuff and you can use it right away. So I can sit here, I can install traceroute tools and start using them, or I could have launched a different container that has SSH and the tools I want. But the reason I do show SSH here is this is giving you a fully featured terminal environment. It's less restricted than the web terminal that I showed you in Horizon, and it can be nicer for this kind of interactive use than the sort of push and pull workflow from Jupyter. You don't have to use the terminal on your laptop to do this. The only thing this depended on was that you provide a public key and I had the private key somewhere. You could do the same thing by staying within Jupyter and using the terminal environment inside Jupyter. Uh, and so this can be useful for classrooms or other cases where you don't want to depend on someone having the local terminal. Okay. And now we installed this, and now we're making a trace route out to Google from where this device is. And actually, I didn't look in advance to see which device this was running on, but it looks like this is actually one of our contributed devices that was deployed over to WinLab at Rutgers in New Jersey. And it all still is working like it was local. So I've got a good question about how is the authentication handled for uploading and downloading the files to the container and generally injecting things. So this is architecturally, the way this is working is that on the back end, the containers happen to be running in Kubernetes, but we have wrapped an OpenStack API, the OpenStack Zune API and service in front of this. And so what's happening up here in the context choose site and choose project is we are actually authenticating to the Chia Edge OpenStack control plane. And so when we run these different API commands, the get devices, the make a lease, the create a container, um, this command is interacting with the OpenStack Zune container service using those OpenStack credentials. And the same thing is used when we're uploading files, downloading files, and executing commands. Under the hood, what's happening is there's a WebSocket interface requested from the Zune API. That request is authenticated with those credentials. And then that WebSocket is used to just push basically a shell command over to upload or download the file. It's actually the same mechanism that, say, kubectl exec uses. It's using privileges to get the socket connection, and then it's sending just raw shell commands over that connection. So that's actually what I've got for these quick demos and examples. I've got a few more slides that are mostly about best practices, more advanced topics, ways to interact in kind of richer ways, and features on our roadmap. Let's get this going again. So this is just summing up a few of the kind of best practices. Yeah. So sorry, Mark just sent me a message. So I think this is actually a good time for Q&A. I can leave some of these things up on the screen to sort of promote discussion, but I'm also happy to, just do something interactive. We've got a bunch of references on, how to make good containers, what containers we have as examples. Um, One of the things that's not currently as specified is how do you add your own containers, especially if they're not ones on our list. And that's the thing that I've most wanted to sort of have a discussion about what kinds of peripherals are people interested in, and what are people looking for in terms of being able to find things out about the peripherals, know that they work, use them, and so forth.
Great. Thank you, Mike. I wanted to leave a little bit more time at the end for questions and answers. I know we have a couple people in attendance at least who have used Cheat Edge. But if there are any questions about what Mike went through, feel free to either raise your hand or put them in the Q&A. And there's not a ton of people here, so we're more than welcome to have people unmute and ask their question live as well. But it looks like we got a couple questions. So Mike, take it.
Okay. Yeah. So I've got one question is about if you've got just a generic Python script in a Jupyter notebook, how to go about running it in the container. Uh, the answer is uh, so the simplest thing is if it doesn't have any dependencies, you can pick more or less any container. And let me actually just go back to this example for reference. I put in one of these windows. It's always too many windows here. So anyway, you can just use the container.upload method to shove any script over. That's what we were doing. Where did I have it here? Yeah, so that's what I'm doing in this line here is there's a few extra lines here just as convenience to say what directory am I in. But all it's doing is taking this script, which is right here in the Jupyter environment, uploading it, and then using execute to say Python run script. If it has a lot of heavy dependencies, you would either need to install those dependencies with something like pip install first, or bake them into the container image to speed things up. So this was one method is using this upload to run it. Um, you can also just run things directly via, just having a string command, or as we showed in the sense hat one, which was this one. Um, for something quick and dirty, you can also just have it as a string block and execute that directly. I don't really recommend this, but it's nice for quick and dirty things. But yeah, I would say the upload is the most useful and most generic. The other thing is you can always run commands to orient yourself, running ls and other things to navigate. Okay, and see, Rick's got some good questions. So about how do we support LLM inference and just that pattern of accessing sensor data, doing some edge inference or edge processing on it, and then running it elsewhere. We've got a bunch of users doing this actually. Uh, the nice thing is that all of these LLM tools, or not all of them, but most of them are already available in containers. And you can just use that as a base image, run it more or less natively here. There's some cases where you might need to, again, add dependencies for like the PyCamera library, in which case we do make our Docker images, not just the image available, but we also have the Docker files available that will show you how we got the different sources in here. So you're able to use this for customizing. And so yes, LLM stuff is something we do very much want to support. If you look at our new docs, we have a bunch of details about the versions of CUDA and other acceleration that are currently supported. That's something that's in a little bit of active change right now because NVIDIA has deprecated the oldest Jetson Nanos, but we'll have some more examples of that up soon. Uh, Quick question on private repos. Yes, we do support them. There is a docs page in that same Git book that says how to use the private repos. Uh, if it, I will admit that it hasn't been tested recently. If there's a problem with it, let us know and we'll get that fixed. Because private repos is a in-demand feature. Got a question about other devices that can be used. You know, cryo-EM is something, so I'm kind of reading this live. Um, but I've had other requests about stuff involving cryo-EM data. Um, I would say that we've got a really wide range of devices that can be used. Off the shelf in terms of the edge devices, we support right now everything that OpenBalena supports, which is, something like 100 different devices. And we're just using that as a consistent underlayer to handle all the operating system wrangling. Something that we've been looking into testing out is there is ostensibly sort of generic x86 support, but I haven't gone through trying that yet. For these sort of large data collections, it would be it'd be interesting to find out how much data it is, what the data rates are. Something we've looked at in the past with other collaborators is, you know, sometimes the context of interest is just the device is attached to a network where other interesting things are. And so, do we want to do latency or network bandwidth tests? We've got people working on running like perf sonar and other network measurements. I think it would be really interesting to see about using this to collect and process and upload this cryo-EM data, but it's hard to answer more concretely.
Great. Any other questions, comments, complaints?
Well, I can say that I'll just add a quick note about, kind of what we see as next on our roadmap, but also that this roadmap is intended to be a bit collaborative because we do want to make sure that we're doing stuff that is actively useful for people and that folks want to, use. And so the one of the things next on the roadmap is enhancing our support for bringing your own peripherals. And I've got this slide over here. So right now, the all these device profiles do is just pass stuff from slash dev somewhere into your container. But there's other stuff that would be interesting and useful for consuming peripherals, such as what libraries does it need? What container image should you use? Is the peripheral working? And so we're looking into improving this framework so that when you enroll a device or otherwise manage it, you can say, this has this kind of camera and it needs this container, and here's a command you can run, and if it outputs success, then the peripheral's working. And that will give richer data to other users who want to be consuming that device and consuming that peripheral. But the details of this depend a lot on the kind of things people want to use. And so that's why I'm bringing it up. If you have thoughts, please feel free to reach out. You don't need the answers right now. We've got the Chameleon forums, which is a great place for this. If you've got specific things, the help desk or the contact email is a reasonable way to get in touch with us, or just email me directly. And I'll make sure that all this info is available along with the webinar slides.
Yes, thank you, Mike. Yeah, we will be uploading this. I will drop a few links in the chat right now for some of the things Mike just mentioned. And we will be uploading the webinar recording and slides to our webinar page, which I shared the link for earlier in the chat. And be sure to keep checking that page for future webinars. We do have one coming up in March, so check back in, and we hope to see you at some of the webinars in the future. Thank you, Mike, for the presentation, the tutorial. And thank you, everyone, for coming and learning more about Chia Edge.
Yep. Thanks for listening. Hope to see you guys as users.
Take care.